Okay, so the first thing, so first question, first part is to find the median for the variable at this nonsense. So open up Excel. So we must find what mean pressure. Then so basically to find the median, you just click equals to median. Therefore you drag from the second one all the way to the last one with Control Shift down, and you'll get your answer of 1011. So then the second part is to find the mean point of the dew point, the mean of the dew point. So you go to the dew point, after the same thing, but instead of equals to median, is equals to average, as they want to find the mean. So you just Control Shift down and you select everything, and this you'll get an answer of 23.62712. Now the next question is to find the average daily rainfall amount with a bar chart for each month. So we are highlight. So basically it's the most tedious job of what they want. Rainfall amount. So rainfall amount is here. So now you must look from, you take the rainfall amount from 1st January all the way to 31st January. After you then to find the mean, find the mean is equals to average then the January, and you do the same thing for February, March, April, May, all the way to December. Then the next part is to find the mean temperature for bar chart for each month of the year. So you just basically do the same thing as you did for rainfall. So you just put average, then you find the January. You find for what do you want? I forgot. Mean temperature. So mean temperature. So you, again, you look from January, so 1st Jan all the way to the 1st Jan, that's right, 1st Feb all the way to 28th Feb, then so on and so forth. And it's the same thing, so same thing for everyone. So we equal average and the whole thing. Then the last question, discuss your finding in B and C. Okay, so my findings was the average, the highest average rainfall amount for 2015 is 9.74193 in the month of December, as you can see, highest. Then the lowest is 0.671429, which is the month of Feb. So as you can see, so most of the rainfall amounts are found in the second half of the year. As you can see, that from July onwards, it's all very high, higher than previous. Then the next part is the highest mean temperature is 29.05, which is in the month of July, and the lowest is in January. Yeah, it's 26.85806. The highest average rainfall amount for 2015 is 9.74195, which is in the month of December, as you can see. Then the lowest is 0.671429 in the month of Feb, stated here. Most of the high rainfall amounts are found in the second half of the year. Here, as you can see, from January onwards, it's all very high, especially December, but it's all very high, higher than the first half. Then the highest mean temperature is 29.05161 in the month of July. Then the lowest is 26.85806, which is January. So most of the high are found in also the second half of the year. you can see compared to the first half from May onwards, from June onwards, or July 29, 28, 28, 28, 27, 27, at least 26, 26, 28, 28, 28. See that the second half is more high mean. So B and C are not really related. Even though most of the higher average rainfall are found in the second half, so same goes as this thing. It doesn't relate though, because even though it doesn't mean December is 9.714 average rainfall, doesn't mean it's the highest here for mean temperature. So, and it doesn't correlate also. So as I state here, where do I state? So, but highest average, I mean December doesn't mean relate to highest rainfall amount, or vice versa, or doesn't mean lowest also. So it's impossible to plot one graph based on this graph. So I cannot plot the average rainfall amount 2015 based on just looking at average mean temperature. It doesn't give me a rough gauge also, because December here is highest, but December here is just like the middle. It's not even, it's like close to the highest, but it's not really that high as compared to October, September, and June. It's like almost one of the lowest. So it's impossible to plot. And here July here is like very like close to, not close but halfway. It's in a halfway point now, but when you see here July is the biggest. So it's impossible to plot, if you know what I mean, right? So next question. Confidence at 95% in intervals level. Confidence interval to find out the mean daily max temperature in Singapore. Okay, so how do I find mean? So they asked to find the mean daily max. So you go to the mean daily max, which is here. So you just control shift down to select all, then you must find the average of it to find the mean. So standard deviation S. So you just use the same thing as mean value to find the standard deviation, but it's sample size. Yes, because this one is asked in Singapore, so we're assuming every year, but only the statistics they gave is only 2015. So we know that this is only a sample out of all the years, and that's why we use .s. So for Z alpha, Z alpha 2, so it's the same thing, we use sample. So why 0.975? Because 95% it was 0.95. So 1 minus 0.95 is 0.05, and 0.05 divided by 2 equals 0.025. So what? So 0.95 plus 0.025 is 0.975. So why is it 0.975? Because this graph, there's something called tails at each end. So 95 confidence interval. So to find that, right, well, actually plus one tail inside 0.95. So the two tail equals to 0.05. So one tail will be 0.25. 0.025. So let's include one tail in, that's why we plus 0.025 to get 0.975. So size is 365 plus in that year, particular year, there's only 365 days. So upper bound, as you can see, the method is mean plus Z alpha times standard deviation square root of size. So that's how you get upper bound. In lower bound, you just minus. You can see upper bound is just plus, lower bound is just minus. Mean minus, the sign is mean plus. So F, what is F? So they claim that the daily mean temperature is at least 31.7 degrees Celsius. So the mean is, you can take one on top, it's the same, standard deviation is the same, but the Z alpha is different, because instead of 90% verified confidence interval is 5% level of significance. So that's why we can use 0.05. So size is the same. So the claim is at least 31.7, means it's including 31.7 and more. So that's why it is under H0 because there's an equal sign. So if H0 is more than or equal to 31.7, H1 will be less than 31.7. So the critical value is standard deviation is not, I mean sample size. I mean because it's sample 0.95. Because 1 minus 0.05 is 0.95. And why is it minus? Minus because the claim say is more than 31.7. More than 31, so you may consider everything on the left, so it should be everything should be minus. So as you can see, the steps are mean minus claim bracket divide by standard deviation over square root of size. Then you get the answer. So step 4, the power, we check whether reject and reject. So since 2.571175745551 is more than the critical value, it does not lie in the rejection area because it lies in the unshaded area. So therefore we don't have sufficient evidence to reject the null hypothesis at 5% level of significance. So G, do the findings E and F agree with each other? So E and F 95. So we look E and F. E answers up wrong is 31.999, 99162, 31.73934. And here the claim is more than or equal to 31.7. So the findings do agree with each other. First, the lower bound here is 31.3934, which is more than the claim, which is 31.7. So hence, and this also supports the claim that it's at least 31%, so it could be more than 31%. So as I was saying, so there's, I have to repeat again, so there is insufficient evidence to reject the null hypothesis at 5% level of significance. Yes, you can read here. So to reject the null hypothesis at level of significance.